Robert. Yeah, so this is the session about research ethics. When I was a PhD student, research ethics grad course was mandatory. I don't know how it is in your university. Do you have a research ethics grad course mandatory? No, Western is the same. So we don't have any mandatory research ethics course, but I went one when I was a grad student because that was actually the only mandatory course for grad students, and that you will soon learn why. And where do I have that pointed the other way? And yeah, so we will. There is a lot you can say about research ethics. So, but we will focus on you as a researcher, right? There are also the ethics as you as an editor or as you as an employer and so on. But we will focus for the researchers and also engineers, because they are very closely connected. You know, the code of conduct for engineers is very, very similar to that of scientists. So we will go through a number of cases, cases for thought, I call them, different types of misconduct and fraud, responsibility for misconduct, which is really important to remember or to know about, because you might be responsible for someone else in your group, and that is important to know. And authorship of scientific papers, always a very hot topic and discussion topic, and publication, falsification, and artificial intelligence in research. Okay, so this was the wrong direction. This is the discovery of pulsars. Has anyone heard about that? No? So it was Jocelyn Bell-Burnell, who was a grad student in physics, and she was like in the telescope. And at that time, it was 1974. No, it was before that, when she did that research. They didn't have computers, so she was basically, there was like a line putting all the signal, and she was reviewing meters of paper every night, right? That typical grad student life. And she found that there was an anomaly of the signal from the galaxy she was investigating, and she said there must be pulsars, and I don't exactly know what that means, but it's some physical thing with a, yeah, maybe someone can explain. But so she went to her professor, and he said repeatedly it must be a mistake. So she convinced him in the end that this wasn't a mistake, and he was actually the one who got the Nobel Prize, and she was not even mentioned, right? So this was very controversial later. So she helped build the interplanetary scintillation array over 2 years. She noticed the anomaly. She convinced him that it was actually something real. She reviewed sometimes 29 meters of paper every night. And she had to be really persistent in reporting the anomaly, and faced a lot of skepticism. And then she was excluded from the meetings and also from the Nobel Prize. But she didn't think much, because at that time, women weren't, yeah, they were, you internalized the certain type of suppression that society has, and she did that as well. So it was first much later that she actually agreed that there was misconduct in attributing the invention to her supervisor only and not mentioning her. The paper that discovered this pulsars had her as the second author, and the first author was her supervisor. And yes, this was in Nature. Yeah. So already at that time, another big physicist in that field was saying that there is, it was not good that she was omitted. But she would first in later years agree. And she said the fact that I was a graduate student and a woman together demoted my standing in terms of receiving the Nobel Prize, and she believed that at that time, right? So she didn't fight it then, but later it was one of the big controversies when it came to the Nobel Prize. I don't know if you have ever been to Stockholm, but there's a Nobel Prize museum, and there you can read all those stories and controversies. You will notice that women have been historically excluded. There are a number of them. Lise Meitner, for example, never got the Nobel Prize. She discovered the Auger effect, which was not even named after her, because it was Pierre Auger who was later discovering the same thing, who gave it the name. So so this is about innovation or discovery, like who is the inventor. And maybe in engineering and in science, it's very seldom that an innovation or a discovery is made alone by one person, or even by a few persons. You have always this network of contributors. So it is very, very difficult to find out who actually was the inventor. And there are also different rules for patents and for papers. So for papers, it's a scientific contribution that matters, which is could be just data analysis or conducting experiments. But for patents, it is an innovative contribution, which is different. So it must be something different than what has been done before in the field. Okay, so that was one of the cases that I wanted to show you. Do you know any other where innovations or discoveries were controversial? Which one? Tesla? Oh. Oh, yeah. Yeah.
The original innovator was Tesla.
Ah, yeah. Okay. And who got the glory? Yeah. It was also in the old times, it was often, the problem was that papers, the mail way was so long, right? So you submitted a paper and 1 or 2 years later it was published, and it depended on where you started to submit it to. So if you, for example, were in Germany and submitted something to an American journal, it would need to be shipped over the Atlantic. So sometimes it happened that someone in America was faster. So that was very often in the old times the problem. But still today you have issues where hierarchies and historical exclusions play a role in assigning the glory to discoveries and innovations. So William T. Summerlee, that is, so he was born in 1938 and was a dermatologist and a medical researcher, and he engaged in scientific fraud. And he did that during his, was it postdoc? I think it was postdoc. So he claimed that he could successfully transplant skin without any immunosuppression. You know maybe that when you transplant organs or skin to from one body to another, it would be attacked by the immune system in another one, right? So he said he could transplant. He did that with mice, and it was a big thing when he published that. But scientists were unable to replicate it, and that was the cause that this was discovered that it was fraud later. So a lab assistant in his lab noticed that one of the white lab mice had a dark patch of skin that was just painted with a Sharpie. So yeah, and so then when they actually investigated it, so after other labs were not able to reproduce it, they noticed it was fraud, and they terminated his position, and that was at the Memorial Sloan Kettering Cancer Center in, where is that? New York, right? So at least it's a famous one. So yeah, and then so there are several contributing factors. So this person had to fix partially his own funding because he didn't get a full position. His supervisor was Robert A. Good, and that was a very busy supervisor who published 700 papers in 5 years. And the committee that later investigated this case freed the supervisor because they said such a busy supervisor cannot detail supervise the student. And the question here is, who was responsible for that fraud? What would you think?
I think they're both kind of responsible because as a supervisor, you are supposed to review your students' work and like make sure that they're doing everything ethically and appropriately. So, like obviously, the students shouldn't have done that ever, but it is still on the supervisor to review and make sure that it's legit.
Yeah. So this is the general truth. Of course, the person who is actually doing the fraud is the main responsible in all cases, but there are several people, and those include the supervisor. Unfortunately, I should say, because I am one, I can really well understand that it's impossible to detail supervise anyone in the lab all the time, right? So if someone really sophisticatedly tries to make fraud, it's almost impossible as a supervisor to notice that. So yeah, we will come to mitigation processes from the supervisor, but it's but it's also the co-authors. So if there were any publications, the co-authors could also be held responsible. Because if you are a co-author on a paper, you are responsible for the entire paper, not only for your part. So that is one of the things I want you to remember. This is another example. So this, and in the previous one, it of course had a lot of effects. So there were other people trying to replicate it, and they also killed a lot of mice, right? So there are not only economic effects of this fraud, but also suffering. And maybe they even did a human study. This is also an example, and unfortunately, I will show you some statistics later, but in medicine, the consequences are quite big for fraud because you could, kill people. And this is one of the examples that was very controversial. There was it was a retraction in recent history. So 1998, there was a claim of a link between the MMR vaccine. MMR is measles, rubella, and I don't know the English word for the first month. Yeah, and so one of the most common children vaccines, and autism. So this link was published in this paper, and in 2004, 10 out of the authors issued a retraction, but the paper wasn't fully retracted and removed from the publication until 2010. After investigation found lack of ethics, committee approval, and as well as financial conflict declaration. So the study was partially funded by a homeopathic anthropologist, and that wasn't declared. And there was also dishonesty about the reporting of how participants were recruited. So they were, for example, they recruited the non-vaccinated children from wealthier families that were generally healthier, and the vaccinated ones from non-wealthy. So there was a bias that wasn't declared, and that gave the good results that they wanted. So the problem with this paper was that it had a huge effect. So we see a lot of measles outbreaks basically because of that still today. Also in Canada, there is a big, a lot of people are against measles vaccine, which is one of the most safest vaccines. And the reason is this paper. And I'm from Germany. Anthropologists are from Germany too. So in my relatives in Germany, there's a big yeah, a lot of people are not vaccinating their children, right? So it had a huge impact on public health. Yeah, but it was there were research ethical problems. So it was not fraud, but it was undeclared conflicts of interest, no ethics, and a selection bias. Yeah, so this is an example that had a huge impact, and I would argue, so here it says in 2019 in Samoa there were 83 people mostly killed because of measles, but today it's much more. We see it in almost all countries researching. And this paper was one of the main arguments. Good. So, stem cells from cloned human embryos. And this is another example. So, quite recent case. There was a big stir. So, in 2004 and 2005, the papers claimed that they extracted stem cells from cloned human embryos and created a patient-specific stem cells line. So you can imagine that with that you can cure a lot of diseases, because stem cells can become any cells, and if you can make them from cloned embryos, you can take them from that person. You don't have the issue with the immunosuppression, and you can basically cure them from anything they have. So that was, of course, a big impact, and both papers were later retracted after the investigations found that data has been fabricated, as well as the ethical breaches in regards to how the donor eggs were attained. But then, by then, already a lot of people, because this was such a big impact, had started their own funding projects or funded projects, so they used a lot of money, public money, and probably also lab resources into the wrong direction of research. Yeah. Yeah. So, and this, right. Yeah, and they, the other people that used that research to make their own research, they were actually using monkeys. So they also, there was a lot of animal suffering because of the wrong original paper. So, good. This is, so now you wonder how common is it among researchers to have this kind of fraud and ethical breaches. And here is the statistic. So how common is it? If you look at the retracted papers, the majority of them that are retracted is because of fraud or suspected fraud. The other ones are error, plagiarism, or duplicate publication, which of course isn't good either, right? All of them are ethical breaches. You see that retraction goes up with time, but also the general publication goes up. So, yes. So we have the majority of retracted papers is because of fraud. So let's look at how, oh, and I might not have that. But yeah, here. So a meta-analysis in 2009 that based on 18 surveys involving in total 11,600 researchers, they said, so about 2% of them would admit to having fabricated, falsified, or modified data at least once. And it's very likely that that number would be higher in reality, right? Because nobody, yeah, even in an anonymous survey, you're not necessarily admitting. Yeah, so, and then except in the cases where it really has a big impact and a lot of other labs start research, it will not necessarily be noticed. So a lot of possibly fabricated or falsified data might be published and will never be noticed because it's just not important. So yeah, that is approximately. So we have a certain percentage in researchers. There have been some other studies on psychopaths among researchers, and they say that like if you have a psychopath in so psychopath means you are scoring extremely low on empathy, and so you have no you don't feel for other people, right? So it is you don't necessarily understand the need of your responsibility to help other people or to not harm them. So psychopaths are, I think, 2% in the population in general, and then it depends on, so this is a natural occurrence. Some people will scale low on empathy. That's basically the genetic diversity we are in. If they get supported, if they don't get supported, they are more likely to be criminal later. And if they get supported, they are more likely to lie. And when they are in the scientific community, so psychopathy is highly correlated to fraud. So this might be one of the reasons. So we can never expect all scientists to be good research ethical people, right? Because there is just, humankind just has a certain diversity in personality. But there are some environments that can be protective or mitigating for it. So if you, for example, live in a very suppressive, you have a supervisor who's very suppressive and wants you to generate certain data, then there is a higher likelihood that some students will do that, right? So also higher economic pressure. We see a lot of, in China, among the medical doctors, some of their positions require them to have certain papers. So there's a very high incidence of having that they pay someone to write a paper, right? So this kind of ethical breaches are organization made because the system is like that. Ideally, you don't want to have systems that promote fraud or ethical breaches. You want to have systems that allow you to make mistakes and that allow you to report negative results. So that is, and you don't want to have someone who says, take out that bad data so we can publish it in Nature, right? So, and even Nature, the paper should be positive to data that are not fitting the hypothesis, right? So, because that would be ideal. Good. So I have a question. No, this is a question. Nibble practices. So in terms of so in clinical trials, you always have to make a protocol before you do clinical trials, and if you then don't follow it, it's a questionable practice. It's not necessarily fraud. It's just not correct. Same in engineering, if you don't follow the standard operation procedures, right? Poor reporting or biased reporting, especially in clinical trials, so putting conclusions that you cannot really draw, maybe misinterpreting some data or even excluding, but excluding would be even worse. Changing protocols after study has already begun. So this is a very bad thing in medical sciences. It's very common in chemistry and material science, I would say. And the reason is that I think there are two reasons. So in biological sciences, like medicine, you have so many variables. So the results can really vary because of a lot of factors. One patient is never the same as another, right? So you have to really stick to your protocol to have meaningful data. And in material science, there is, you can usually go in different directions. There is less risk that a measurement will show you the wrong thing, and you always cross-check it with other measurements, right? So I would say this is more important for medicine, but not so much for us. Also in biological science, you always have a hypothesis first. In material science and chemistry, necessarily have that. We might have a research question. Yes.
So if you changed your protocol like halfway through,
Yeah.
or like a 10% through, would you just explain that in your paper though, that like you changed your protocol and why, or would you just exclude the beginning?
So, for example, in your case, let's say you have a certain research question or hypothesis, and you would say this is much worse than that, and you would halfway through see they are not different.
Okay.
So then the question is, do you need to spend your remaining time to basically show, yeah, there is no difference? If you have a medical question, like, is this drug working or not, it makes sense to continue, even if you know there is no difference. But if you have, but you already know that this is results you don't want necessarily to write a paper about. So then you could stop and change direction. And then you could either report what you had in the beginning or what you had halfway through. Yeah, so it makes sense in those disciplines. I don't know if anyone has a different opinion. Yeah. And so this is more a problem, especially in biological sciences, but if you change the hypothesis or research question to fit the results, that is a big problem if you have a lot of variables, because theoretically, statistically, you can get a difference somewhere, right? So, yeah. This is more common in our field, I would say, reporting results and conclusions that are not supported by the data. Very, very common. I see that almost always in the papers I review. So one main reason is that you have no understanding of all the possible mechanisms that could occur. So you just throw the first best you can think of as a conclusion, but that's not right. A worse example is if you have, for example, an industry project and you want to give them the right conclusion. That's even worse. Yeah. And it's, by the way, a very big work of the peer reviewer to check that this is true. So this is actually the main thing the peer reviewer has to check, if the conclusions are supported by the data. So data dredging or p-hacking, so this is when you have a big data set. You could do that because you have a lot of ICP-MS data. Let's say you have 10 elements, right? And you have a lot of different salts and a lot of different time points. And now you want to see, is there a correlation or is there any trend? And you could put a statistics program on this and say, find me the significant difference. And then you're just reporting that and make your story around that. And this is also very common in medicine research, where you collect a lot of parameters like socioeconomic factors, medical history, blah, 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 blah. And you have a lot of patients. And if you have a lot of patients and a lot of parameters, you can always find a significant association. Like, for example, the people that eat a lot of chocolate, they have less heart attacks, right? But this might not have been your original research question or hypothesis. So it could just have been coincidence. Because you have a big data set, there is a probability that you find at least one significant correlation. So that is called p-hacking. It's not very common in our field because we usually don't have so many parameters. And even if we have, it's not that interesting to report, like chocolate and heart attack. Yeah, but this is a big thing. So we really need to get better in publishing negative data or data that is not good, right? And I hear that a lot from students. This data was not good. What is good data? There is no good or bad data, right? All the data tells you something. If it was properly documented and you can rely on it, it means something.
Thank you. Looking over there.
Yeah, so that's very important, and we need to be better in reporting it. And as peer reviewers, we need to be better in letting those go through. we should ask them for good data or for it's yeah, if it's properly reported, documented, it's okay. It's good. It's actually someone else might do exactly the same experiment because you have not published it. Think about that. Yeah.
Just wanted to say something.
Yeah.
Because it's like, for example, in my field, I'm just looking at the article, and you know, it's like you should break something to happen. Because all of the articles and all of the data that until now published, also like I can say many of them are like you just read the first paragraph of the starting point, and at the starting point you know that what you should expect, and people are nicely present that yes, this is just the thing that you should expect. And you know, sometimes it feels like do not feel good, and this causes you.
You mean
to
unexpected?
have bad data.
Unexpected results.
Yes.
But it's the unexpected results that you learn most from. Actually, my biggest discoveries have been unexpected results. It just means you don't understand something yet. There is maybe one more factor in your system that you haven't thought about. I can give you an example. I was an undergraduate student. I was doing copper in immersion tests and measuring the copper ion in solution, ICP, right? And I was doing that, and one day another student needed the fume hood, so I switched the setup to the open bench. Suddenly I got double the readings, and I didn't understand it, right? The only thing I was switching the setup to another table. And later I understood this is because of the semiconductor band gap of copper oxide, which is so close that light matters. And I had much more light on that open benchtop. So this gave me a really good insight. It took me about half a year to figure that out, and a lot of people discussions, right? But so this might be, right? It might be unexpected because you don't understand it yet, or because your system is irreproducible in a way that you haven't found that one factor that would make it reproducible.
Yeah.
But even irreproducible things are good to report, because other people will not, they will have the same issue, right? We call that method papers.
I think it can help people to not go through, because
Yeah.
when you do not publish a data that is not, okay, nothing happens, nothing special happens, it causes another researcher to go, and you will just go for in a direction or a situation that gives you specific results. So another person is going to work, I mean, in a similar subject, and it's like, okay, this person did, for example, in this pressure or something. Why? There is no specific reason, but the reason was that they didn't get any result in another, situation, and they didn't publish that nothing happens with the other parameters. And when they did not publish that, you have to go all the way through that, say, okay, and you also put it away, go for another parameter.
Exactly.
And it's like just creating lots of
so much
time
money,
waste.
so many graduate students that suffer. Think about that. Yeah, we really need to publish more negative bad results. When you see, I noticed that in when I put online in my team the thesis instead of the papers. The papers are public, right? The thesis, they were like, they also had this issue. They also, yeah. So obviously it is published somewhere, but we need to be better publishing it in papers as well. Yeah. Okay. Conflicts of interest. Which conflicts of interest do you need to report in your project? Do you have industry funders? So those need to be declared. So you can say, this study was funded by X. They discussed the results. They did not directly influence this paper, but they funded the research. That would be a conflict of interest, but it should be declared. If you don't declare it and someone later finds out that this study was actually funded by someone who has an interest in in it getting a certain result, that would be a research ethical breach. So that is one. Patents. If you have a patent, like let's say you have a patent about a new material, and then you publish a paper that says that this material is great, that would be a conflict of interest. A company spin-off that is going in that direction, right? Yeah. Any other like this, right? So for medical researchers, it's very often if they have been invited somewhere to speak, that is seen as a conflict of interest that they need to declare. Someone paid their travel plane ticket, right? Or they have got a wine from the pharmaceutical industry, and then they are writing a paper about their drug, right? That is a problem. Excessive self-referencing. Do you know some journals that have some limits on that? There are some. They say usually 25%. You should not self-cite more. And self-cite means any of the authors. So any of the authors, not only the first author, right? Any of the authors is anywhere in the citation list. That should not be more than 25%. That's a good rule of thumb. It depends on the field. Sometimes it's hard to get lower. Sometimes it's easy. Depends on, if basically your group has done all the work before. But so there are many reasons why you shouldn't self-cite too much. One is that it doesn't look good, right? But the other is it just gets cited, because the best way to get to expose your work is to actually cite someone else. Yeah. Right. So that is so really try to make a literature search and get the right. It's always harder to find others' work than your own group, because the terminology might be different. There's slight differences. You might not find it easily. Yeah. This is a predatory journal. Have you heard about those? You might already be exposed to some that send excessive emails. Send me your paper. You will get a waiver of the article charges. No? Yeah? Someone? Ed probably gets a lot.
Every day.
Yeah. So that is a sign if you get a lot of emails from a journal saying, yeah, we have a special issue for you, right? So this is unethical, but from the journal side. So, there's some examples of unintentional misconduct, and those are when you do medical or people research, would be not getting written consent or ethics permits, submitting a manuscript to multiple journals. Never do that, right? You always have to only submit it to one, wait until it's rejected, and then submit it to another. You can put it on a, if you're really, really in hurry because another group will maybe publish it before you, then you can put it on a pre-publishing server. And that way you have made sure you get the inventorship or discovery. But yeah.
This might be silly, but why is it bad to not submit to multiple journals?
Because you cannot duplicate, you cannot publish twice, right? So it could be that both of them would publish it at the same time. Yeah. This is called salami slicing. One study that is split into many different. You also see the opposite, people that try to put several studies in one paper, which is, so if you cannot explain the main study in one sentence, that's usually a sign you have put too many studies into it. But salami slicing would be, let's try to get more publications, because one of our career goals is to have many publications, or many of the employers look for that. And this is like, oh yeah, let's make this. We just take this experimental condition, this pH in one paper, and then we take another in another one. but the overall research question was actually answered by all of this, right? So, yeah, it would be not good. A journal, it would also be, yeah.
So, one like what you said, so I'm inspired. What is the situation whereby if you're putting the full study in a paper, you're going to do writing a thesis in one paper. Is it not better splitting it into two? Like the number of pages if I come up with 10 or 20, nobody's going to read them.
Yeah, so it's an interesting question. We've had this issue before where we think we have a body of work, but it ends up being a very long paper. So
Yeah.
in one case, it was 60 pages. And we've actually had the editor say, well, you need to split that up into 2 or 3 pages.
Yeah, that's okay if the editor says that. Then you just make part 1, part 2. But I have done 2 times. I have tried to do part 1, part 2. It can happen. Yeah, one of them gets rejected, right? And then or both of them, because one of them would get rejected. So not good idea. Don't do that. But if the editor says you should split it up, fine, do it, right? And just call it part 1, part 2. But it's very difficult to publish part 1, part 2.
The other thing I've noticed recently is that editors and reviewers don't want to read long papers. So I've been advising my students to keep papers short in the last few years.
Yeah.
But that does open you up to the criticism of long publishing, especially
Yeah.
if papers are reviewed. So it's a fine balance.
Yeah.
I think as long as you don't do it on purpose,
Yeah.
right, to boost your publication numbers, it's probably okay to have shorter.
Yeah, you can. Yeah. So now with my group, I have so many people that have so much data, and very often we end up with a short main manuscript and a big supplement. It's maybe not the best way either, but at least it publishes it, and then you have you can cite it even if it's in the supplement, right? But you need to make sure, if you really want someone to see the supplement, it shouldn't be there. It should be in the main manuscript. But if your entire story is in the main manuscript and you just support it by data, you can put that in the supplement, like the details. So yeah, it's a balance. Yeah. A journal that does have no retraction policy is the bad sign. So intentional misconduct might be plagiarizing, and that content or ideas from anywhere else includes the one time I had published a perspective paper on the role of proteins in corrosion of passive metals, and then I was a reviewer. No, I was seeing someone who cited it. I checked that paper. It was pages copied from my paper. And I was thinking, should I email the editor or should I? So those authors obviously are on my blacklist of people, but they made like the balance between still citing my paper. So it was like on the edge, but it's not a good sign. So don't plug your pages, and yeah, and the worst thing is their paper is much more cited than mine, right? It was the same thing. Okay. Yeah. So don't do that. Oh, that's bad. If you are peer reviewer for another paper that you compete with and you delay theirs because you want to publish first, not a good idea. And this is also why you have the submission numbers, and you always have the date of submission. So this is to publish, right? So you see, when you have a paper published, it says submitted on this date, revised on that date, published on that date. This is to mitigate conflicts about who got it first. And very often the peer reviewer could be your enemy that is trying to delay your paper, right? So that is an issue. Ghost and guest authorship. So we will come to that a little bit later. But ghost means someone who's not on the author list but who contributed, and guest means someone who is on the author list but didn't contribute. And a journal that is misrepresenting the editorial board is also ethically wrong. Or if they say we are indexed on Google Scholar, on Scopus, and everywhere, and that's not true. Or we are part of this professional association. So serious misconduct or fraud is falsifying or fabricating data. Falsifying would be to make it nicer. Fabricating would be to completely invent it. And stealing or plagiarizing data from somewhere else. Using research funds for non-research related personal use. You can use research funds for side projects, but not for personal use. And this is again about journals, imposter or hit jacket, journals like bad journals, unfortunately more and more that exist. And do you know what that could be? Fake peer review and peer review rings? So fake peer review is like journals that say they are peer reviewed journals, but they just have always the same people reviewing everything. And it's not real peer reviewers in the experts in the field. And review rings would be if you have like friends that are reviewing each other's papers. So that is the most important thing. So who is responsible for misconduct? So we said that before, right? First of all, the person who actually does it. And of course, the supervisor, unfortunately. That's a very big responsibility because so every supervisor is basically under the risk of losing their job. And that includes industry and academia because of someone lower in the hierarchy under their supervision doing something wrong. All co-authors, so really all. So if you are on a paper, especially if it's retracted or investigated for fraud, it can kill your career. So that is important. So never be on a paper and don't check the other one. If you notice some fraud or plagiarism, drop out. Say, I'm not interested. You can get my contribution anyway. Yes?
Are there protections in place for it's, as you mentioned earlier, the supervisor is hard to tell whether the main student is doing any misconduct. For co-authors, you might even be more removed, for example.
Yeah.
Especially if the group, there are multiple groups from different universities or different countries or whatever.
Yeah.
Will have almost zero access to data that the main are there any like co-author rights protections for those? Or
There is no protection. The only protection that is usually the case, so if there is a misconduct investigation, which is usually institutional, the co-authors would be the last to be punished. It is usually the main person is the person employee or something that has done the fraud, and the supervisor, but not the co-author usually, but it could, right? And if you have a retracted paper, it doesn't look good.
the follow-up would they look at the relationship that the co-author has with the main author? For example,
Yeah.
if a co-author is say another student in the same group, then they might be penalized harsher than if it were a co-author from a different university who may not have as much of a relationship or may not have much knowledge on the research.
So I had this, so when I was, so this is true, and this would come up in a committee or investigation, but you still might lose your reputation, right? And I had this issue when I was like 10, 15 years ago. We would always be encouraged to work, to collaborate with all people in all the world. International publications would be ranked higher by your institutions usually. If you had a number of papers that had international affiliations that looked good. now I have a lot of problems because of past publications that have international affiliations as co-authors that now are classified as national security risks, right? So I'm now, every time I apply for grants in Canada, I'm flagged, red flagged, and every time I have to explain what is my relationship to that institution. So you have to think about your publications are there forever, right? So it is I have a lot of publications with Belarus, with Russia, Iran, and with China, and all of them are flagged now. And this was before the wars, right? So European Union was sending scientists from Belarus to Sweden. They gave them money. We investigated failure cases in Belarus and so on. Those are now under sanctions, right? And so this is the thing you cannot predict always, but publications are always in the public space forever. And if you have connections to a co-author who's later crushing a reputation or a bad one, and you maybe have several papers with a bad person or a bad affiliation, yeah, it might hurt you later. So, but this does not mean that you should hide in your space and just do everything alone, right? It's a balance. Yeah. And funders and industry partners are also responsible, especially so. It might look bad on them if there is a fraud case, right? Because in every paper we have to declare every funder, and that funder gets also blamed. Technicians and lab staff, if they fabricate something or if they have helped the fabrication, that is also bad. They might be. So the important thing is there is a shared responsibility and there's a shared glory. And yeah, it cannot be without that. Yes, so come to author contributions. You might have seen that in the newer times, they have more and more guidelines on that. So very often you see things like, the credit author statement, and in thesis you have to say the co-author statement and so on. This is really important to get right and to get approved by all co-authors. So if you are the main author writing those, make sure everyone approves them, because this will later, in case there is a fraud or an investigation, this will determine how you might be punished. and so here, for example, it's one of the journals, you see the name, and then it says conceptualization, data curation, formal analysis, investigation, and so on. Supervision, writing, original draft writing, review, editing, right? So the more you have there, the more contributions you had, or if it's like important ones, like for PhD students, it's usually investigation that is an important one, maybe the original draft writing as well. For PIs, like principal investigator, might be conceptualization that is the most important.
Yes. It's a case that happened to you that it is about the supervisor. The student wrote was the first draft writer, and then supervisor just corrected,
Edited, yeah.
Yeah. And after that, there was some issues in the conflict, and the supervisor, without the consent of the student, changed the order of the name and placed the name of the student at the end and published the article without the consent in the first step. After the acceptance of the article, it was notified to the student that your article was submitted and accepted, and the student in that spot understood that the paper is accepted. And because of the conflict, they didn't follow up with the supervisor because they thought that they will not change the order of the name. But this was okay. And then the article was published, they understood that their name as the first writer of the draft moved to the last name.
Mm-hmm.
show that they were the first person, based on a thesis. So after many communications, the journal just mentioned that they talked to the first author, which was the supervisor, and they mentioned that there was no problem. So the investigation is going to get.
Okay. Yeah. So author-order conflicts are extremely common, and there are a number of mitigation methods you can do. Some people would say you should discuss the order in the beginning and then stick to it. I would not recommend that, because you can do that, but sticking to it can also be a problem, because very often experiments are redone, the direction changes, the parts are excluded, right? And whoever was there first or second might not be a main contributor anymore. But the author order should be, it is subject to approval by all authors. And every time you submit, the entire paper has to be approved by all authors. There are several methods. So if you want to survive in your career, you cannot wait until you get approval from all authors every time, because most of your co-authors will never answer you. This is just my experience. So one way to do that is to send out an email. If I don't hear from you, I assume your approval by this day, and then submit it, right? Then at least you have done your duty. Because unfortunately, not all co-authors will read the paper. They should, right? Every co-author is completely responsible for the entire paper, and they have to read it every time it is submitted or revised. And most of them don't, and most of the professors don't either, and this is bad, right? Because things like this might have happened or might happen. Also, if you submit it to a journal, you will get a notification. Every co-author will get a notification today from most journals. So then log in and check. Download the PDF. Right?
In case that the journal doesn't
Yeah, that's a bad journal then. Because this is the duty of the journal to make sure they have ethical procedures in place to avoid those conflicts. And today, for example, Elsevier, all the journals are sending out a notification to all co-authors every time it's submitted. And then you have to check, right? If there's a problem, you still can change things. You still can discuss with your co-authors.
It's weird that they will send out email after acceptance, but they do not send
Yeah.
after submission.
This was the policy previously, and because of this, all these ethical issues, most of the journals have changed it, and not all. So yeah, so the other thing is the acknowledgement. So everyone who has scientifically contributed to the paper, and that the definition unfortunately changes from professor to professor, right? Some professors, and also disciplines, some professors will say, this was routine work, anyone could have done it. Or they will say, they just did what I told them, right? But generally in our field, if you did any experimental work, you would be co-authored. Because our experiments are not easy. But in, for example, other disciplines, data collection would not be counted as scientific contribution. So it's interesting. So whoever did not qualify for the author list is in the acknowledgement. And actually, you need approval from everyone you mention in the acknowledgement, just like your co-authors. You cannot publish acknowledgements without having emailed them. I want to acknowledge you. Here's the paper. I want to submit it. If I don't hear from you, I assume your approval, right? And so this is important. Acknowledgement is as co-authors need approval. You would say, you can very well say here, for example, this one, the authors thank the landowner across Bavaria for kindly allowing us to work on the land. For technical assistance in the field, we thank this person. We acknowledge support from, this was financial support, then love support, all that. And I want to make one important comment. Don't forget the staff, the lab technicians, the scientists that help you to run the SEM or whatever. They are usually neglected, and they can very, very well have done even a scientific contribution. Just because they have a different position does not mean, so in scientific means, everyone who has scientifically contributed or technically should be mentioned, at least in the acknowledgement, right? Acknowledgement, there is no lower limit for mentioning anyone. You would mention everyone who has contributed. And please do that. It will make your life so much easier. Yeah.
One question, if we're sending samples out to another university or commercial, like to a company, so if we're sending the sample and they're doing the data processing for us, would we only include them in the acknowledgements? Would we, if that portion is, like for like just a quick example, I'm sending my samples, I've done hydrogen charging experiments on my pipeline soil samples, and I'm sending them out for like a combustion hydrogen quantification. And then with decanment, and then they've done the analysis, post-processing, and providing a final concentration level. For that kind of work, or for any similar work, how would we cite that or acknowledge that they had done this testing?
The best way is to ask them if they want to contribute and how. If they want to contribute even scientifically, you could invite them to review the paper and to edit it. They might actually be really helpful for the experimental section or even the interpretation. The same for industry partners. I have had many papers with industry partners as co-authors. I know it is not necessarily the predominant culture to do so, but it is much better for the paper quality. Because, it's, as I said, it's not the position that determines the scientific contribution, it's the scientific contribution. Yeah. Yes.
So my question is more like based on what you were saying about people that help you. I felt comes automatically. Like anyone help you, you need to actually get a consent from them to acknowledge them.
Yes, at least you need to try to contact them. So if you are unable to find a contact information, or if you did not get consent, you can still acknowledge them without the name. So you can say, we acknowledge the lab technician of this organization, name withheld. Right? So you can still acknowledge them for their contribution, but you would not be allowed to mention the name.
Second question, how about if they make it mandatory that you have to put them as co-author before they have to do program STM or CDM or something?
You would not. So what I would do is asking them, do they want to contribute? Maybe, but that's usually only scientific, so it's not just data that they run a measurement, right? Especially if they're paid. TEM is a different story because that can be quite a lot of scientific contribution. But let's say they did a really good job in, and it influences the conclusions, it influences the interpretation, and you need it right in the experimental section, and you really need them to write those parts, then they would definitely qualify to be a co-author. The way I would do is asking them to look at specific topics. You don't add them as co-author first, but you say, I might consider you as a co-author, depending on the overall contributions. Because this is why I don't like to fix the co-author order in the beginning. Because you never know the journey of one paper. You never know how many contributed later to it. It can change quite a lot, but you have to acknowledge everyone, and you have to get approval from everyone, and that will save your relations and your career. Yeah. So extreme cases. This was on LinkedIn recently. There was one author who had until June 15 in 2024. So just in 2024, he or she had published 261 papers. So that means 1.56 papers per day, or 2.18 per weekday. Are you able to do scientific contributions? No, right? So this person's probably not even read the papers, right? There might be extreme cases where maybe someone developed like a method that is then used by many researchers and they all put them as co-author. But still, this person needs to read every paper, right? And that is obviously not the case here. So, yeah, that is not good. So, gift is another for guest authorship. So, gift authorship or ghost authorship. I mentioned already the definition, and this is quite common, especially in some hierarchical systems. You can see like, oh, the department chair is always the last author, for example, and they might not have read the paper at all, right? And so this would be gift authorship. Ghost authorship is more often someone in the lower hierarchy, or if you think about medical disciplines, so there are complete companies, even toxicology and chemistry, complete companies that write papers for you. And that's not ethical, because you cannot be sure to double check everything. And that would be ghost authorship, and by definition, everyone on the paper has contributed and nobody else. So the author order, it's really also dependent on the discipline. Some disciplines put it alphabetically. Some disciplines put it, the first is has contributed most and the last least. And what is most common in our fields is the first is doing most of the experiments, and the last has done most of the conceptualization or leadership. So usually the last would be the PI, the first would be the graduate student who has mainly contributed. Yeah. So if the author order is changed or not correct according to the contribution, it is a form of misconduct. But I want to urge you, so it's really, really difficult for one co-author to know all the contributions of the others, because you only know what you did, right? It might be, so it's important to discuss this with everyone, to raise, if you think you should not be second or third author, you should be first, to raise this. But a scientific contribution is not a number of hours, and it could be, but for example, if your experiment was the one that really led to the conclusion, whereas all the work that someone else did was actually excluded or only toned down because it was not leading to the conclusion, but that other person has spent 2 years and you just spent 1 month, and that other person is now first author just because they did so much, right? And that can be a form of misconduct. You could raise it, you could discuss it, but you have to do that during the, a good advice is to do that as early as possible and continuously. And yeah, but I should say it's always difficult to know what the others did. It's much, you know what you did, but they don't know what you did. And it's difficult to know. That's hopefully when you have a good PI, they can judge like the different contributions against each other, but yeah. So this is a form of fabrication, image fabrication, so you can see maybe that the images are similar, and there's two. So there was a program used to fabricate images, and yeah, and falsification would be distortion or adjustment of data, research materials, images, protocols, or equipment. So AI, it is becoming a thing. I noticed that a lot. ChatGPT or other programs. So most of the journals now say you have to have a statement if you use AI. You can use AI for grammatical reasons. You can also use AI to help you writing, but you remain the main responsible person. So you cannot have AI to be your co-author. You cannot have them making responsibilities, and AI can fabricate citations. Don't trust ChatGPT to find citations. It might be a wrong one, or it does not even exist. And whatever they say to you is might be completely wrong. So yeah, I really prefer grammatically wrong text than text that have been generated, because you just don't know if it's true, and it's really, really hard to figure that out, and it sounds so nice. So yeah, also plagiarism is easy to discover. So yeah. Yeah.
When you write a paragraph, you write the main writer, and then you just give it to ChatGPT to just correct it grammatically, or just adding that or something like that. Not even changing the order of words or something, not paraphrasing. But after that, you ask ChatGPT that you write it, it's a yes. I don't know that if journals are checking this way to, for example, give your text to ChatGPT to ask. I don't know. I think for sure if you write it by yourself.
So there is another program. It's called Grammarly that is checking your grammar. It's also artificial intelligence, and the advantage with using that over ChatGPT for a grammar check is that it doesn't take your data. ChatGPT takes your data. Is it not good if you want to publish it, right? And it might be something that you later want to make a patent of, and you can't give it to ChatGPT. So for Grammarly, yeah, even that, I was thinking if we should declare it, but usually for grammar reasons alone, it would not be declared. And if you use ChatGPT for grammar reasons alone, it's not, but you have the full responsibility to check after it has improved it that it's still correct. So that is okay as far as I understand the guidelines. And the problem is, true, plagiarism is easily detectable nowadays. So never use any sources that are published anywhere. Be also careful with taking theses from other students in your group, or first-year reports, or comprehensives, because your colleague might plagiate their own text later and publish it. And then, if you have plagiated the same text, you have plagiated their thesis, right? So even if you plagiate a lab report, you don't know if they plagiated it as well and published before you. This has happened in my group. So it's a problem. And so very easy to detect, which means it could cost you your career. And also, it is nowadays easier and easier to detect if AI has been used in the text writing. And yes, here's an example. Now it is retracted, by the way. Surfaces and interfaces. And the first sentence of the introduction says, certainly here's a possible introduction for your topic. Not good. And this has not been detected by anyone, except, of course, later, the readers. So then it went viral, and then it has been retracted. And the retraction reasons were, by the way, not that sentence. It was, yeah, what was it? Let me check. At the request of the editors-in-chief and authors, it has been retracted. The journal was alerted to the presence of duplicate images appearing at figures 1 and 2 of this article and figures 1 and 2 of another journal article. So that was one. And The investigation by the journal confirmed substantial duplication of text and image data between these two articles. Very bad idea. And that were submitted and already published somewhere else, right? So not good. And all the authors of the other paper were also the authors of this paper. In addition, there are concerns that the authors appear to have used generative AI, which is a breach of journal policy. Yeah. And then the journal says also, the journal sincerely regrets that these issues were not detected during the manuscript screening and evaluation process, and apologies are offered to readers of the journal. So they understand this was really bad for that journal, right? That journal is now world famous. Yeah. And it's actually one in our area. Yeah. So, yeah, the conclusion is that we have to have shared responsibility. You're always responsible for everyone around you as well, which sometimes feels overwhelming. You have the duty to report any breach or integrity ethical issues, but it is very, it's usually a good idea to also be open-minded, because you cannot always know if it really was a breach. When you, for example, are a peer reviewer, you would write that in the confidential comments to the editor, and always write, this seems to be like, you don't say they have made misconduct, because it might be something else than you think. Yes, and there is a course online if you want. The free course by Clary Wade. Here is the link, and it is more for peer reviewers and editors, but it also contains all those examples and leads you through all those data breaches